I welcome you to this session of combinations. In this session, we will take a look at a few basic word problems based on combinations. Let us say there are four people A, B, C, and D, and we want to form a group of two out of these four people, or maybe say a group of three out of these four people. So, in how many ways can we form that group of three? Group number one, that is A, B, C. We could have group number two, that is A, B, D, or maybe group number three, A, C, D, and group number four, which is B, C, D. So you can very well see that these are the only four groups of three that you can select from these four, A, B, C, and D. This particular selection is also represented by selection of 3 from 4, which is represented by 4C3. Those of you who may not have a background in maths and would like to know how to evaluate 4C3, I would suggest you to go back to session number 1 or session number 2, where I have explained how to evaluate 4C3. So all of you know that 4C3 is equal to 4. Now, what is the difference between selection and permutation, or combination and permutation? If this were a question of permutation, then for each group that I have selected, we would also have 6 possible arrangements. So if I select group number 1, that is A, B, C, I would have had arrangement A, B, C, or A, C, B, or B, A, C, B, C, A, C, A, B, and C, B, A. So you notice that for every group I would have exactly 6 arrangements of 3 people. But in combination, we are not concerned with arrangements. We are only concerned with selection of groups of 3. So, in how many ways can a group of R people be selected from N people? You can generalize that as, so number of ways of selecting R people from N people, you can generalize that as equal to NCR. Remember, N is always greater than or equal to R. So with this background, let us solve one simple question based on the same concept. In how many ways can we select 3 people out of 8 people? So we have to select 3 people out of 8 people. So N is equal to 8, R is equal to 3, and we know that number of selection of R people out of N people is given by NCR, and applying the same formula we'll get the value as 8C3. And what is the value of 8C3? Factorial 8 divided by factorial 3, factorial 3, and factorial 5, which is nothing but 8 into 7 into 6 divided by 6, which in turn is equal to 56. So number of ways in which you can select 3 people out of 8 is equal to 56. Now, what would have happened if one of these people or two of these people are not supposed to be selected? Let's say 8 people come for a job interview, and out of which 2 people, let's say A and B, they are not to be selected. So if we cannot select A and B effectively, so what is the value of N now? N now would become 8 minus those people, or minus the number of those people we cannot select. So n is equal to 8 minus 2, that is equal to 6. So effectively, if a few people cannot be selected, then the value of n will reduce by those number of people. But suppose there was another condition in which A and B, they are definitely selected. So if A and B are definitely selected and I have to select, say, originally I have to select, say, 4 people, then because A and B are selected, we don't need to select 2 people. We need to select eventually only the 2 remaining people. So 4 minus 2, that is 2. So if a couple of people are selected, that has a direct implication for the value of R. In this case, total number of people from which selections can be made will be 6, because these 2 selections are already there. So we don't have to consider them, we cannot select them twice. So there are only 6 remaining people. And we have to select only 2 people out of these 6 people. So the total selections would become 6C2. Let us solve another similar question to illustrate this concept. In how many ways can we select 3 people out of 8 such that one person is never selected? So what is the initial value of n? Initial value of n is given to us as 8. And because one person is never selected, he cannot form or he cannot be a part of this group of 3 people whom we will select. So what is the effective value of n? Effectively, n reduces to 8 minus 1, that is equal to 7. Because if we cannot select one person, what is the point in having him from the group of possible selections? So we ignore that one person and now we assume that the selections can be made from only 7 people. So in how many ways can we select 3 people out of 7 people? 7C3, which is nothing but factorial 7 upon factorial 3 into factorial 4, which is equal to 35. 35. Let us take a look at another question. In how many ways can we select 3 people out of 8 people such that one person is already selected? Once again, what is the value of n? The initial value of n from which the total selections are possible is 8, and the value of r is 3. These are the initial values. But because one person is already selected, he can be ignored, he will not be counted in the value of n nor for the value of r because he is already selected. So what is the effective value of n? The effective value of n is 8 minus 1, that is 7. The effective value of r is 3 minus 1, that is 2. So in how many ways can we select such 3 people? The answer is 7C2, which is nothing but factorial 7 divided by factorial 2 into factorial 5, which is equal to 21 ways. Next, in how many ways can we select 3 people out of 8 such that one person is never selected and another person is always selected? Once again, the initial value of n is 8 and the initial value of r is 3 because 3 people have to be selected, and the total number from which the selections are possible is 8. Now one person is never selected. So what does it reduce? It reduces the number of people n from which selections have to be made. And now in this case we have 2 people. One is definitely selected and one is definitely not selected. So we will ignore both these people from the list of people to be selected, and the effective value of n is 6. What about r? Originally we had to select 3 people, But if one person is not going to be selected, we can reduce the value of R to 3 minus 1, that is equal to. So in how many ways these selections can be made? These selections can be made in 6C2 ways. That is factorial 6 divided by factorial 4 into factorial 2, which is equal to 15. So with this we come to an end of this particular session. If you wish to watch more videos or if you wish to solve more questions, please log on to www.pfindia.com. If you want to ask a doubt, please write to us at studentservices@pfindia.com. And if you're watching this video on our website, please use the Ask a Doubt feature. Thank you very much.